Section 1, Chapter 1, Lesson 3. So arithmetic growth and decay, this is kind of, we have this, and then we'll do arithmetic series, which kind of changes the game a little bit before we get to geometric. So this week we'll pretty much do all arithmetic. Next week we'll get into geometric. So many real-life scenarios can be represented by a pattern of numbers which exhibit arithmetic growth or decay. We're going to talk about growth first. So here's kind of our first setup. So to kind of lay the foundation, what this question is going to do for you is that there actually is kind of one key issue that messes people up with sequence and series: where to start. Okay? Now, there's not a right way or wrong way of where to start in terms of your first term number, as long as you know where you are. Okay? And we're going to talk about that in this problem. That might make more sense once we do it. But just one thing I want to say is that I notice a lot of students that make mistakes. It's because they think they're in year 2002, but it's actually 2003, et cetera. They're just in the wrong spot. Their work's great. They know the math part. They're just in the wrong spot. Okay? So this is going to help you understand why there's some flexibility there, just making sure you know where you are. Okay, so this problem sets up the idea of BP, Birthplace Force program in Calgary, enables parents to honor their children by planting a tree when their child is born. Same time, this shows concern for the urban environment, encouraging the growth of city forests. Some of the trees which have been planted are evergreen trees, which grow an average of 12 to 18 inches per year. This program was launched in 2000. So that's a little background of where we're coming from. So the math with it, what we're going to do with that information. So it says an average evergreen tree is 6 inches high when it's planted. June 2000 has a growth rate of 15 inches per year. Two students were asked to determine the height of the tree in June of 2011. Joel formed a sequence of 6, 21, 36, and Jenna formed a sequence of 21, 36, 51. Use the formula in the previous lesson to determine each student's answer to the problem. So first off, why are they different? What did they do different? They start at different spots, right? So there's not a right or wrong person here, but you know, in terms of context, Jenna's is actually a growth pattern, because was growth 6? That's the planted tree. So it started at 6. So I kind of explain it as like 6 is kind of your T of 0. There was no growth yet. Okay? So Jenna started with the first growth. So her T1 is year 1 of growth. So hers is going to line up a little bit easier in terms of comprehending. His, you're going to have to be back 1 because you're counting 0. But let's go ahead and look at what he would do here. So for him, for Joel, his A is 6. We're using the general terms from last class. Okay, his N is going to be, his D is 15. And then here's the tricky part. His N is what? That's the tricky part. It's 12. Because 6 is what year? 2000. So he's counting the 0 year. So if you're counting the 0 year, if you count from 0 to 11, you're going to hit 12 things, right? Because the number 0 you're accounting for. That's the tricky part. Does everybody understand what I'm saying there? So N is 12. If you don't understand what I'm saying, you simply just go, you count all these. That's 12 things. Okay, so you have 12 terms, counting the 0. Okay, so that's what he's going to use. And so when he does this, you simply now you're going T of 12 for him is going to be 6 plus 12 minus 1, whoops, the minus 1 there, times 15. And when you do that, you're going to get 171 with Joel's work. 171 inches is the height of the tree in the year 2011. Yeah, it's a minus 1, sorry. It's just really bad. Just got scribbled there. 12 minus 1. Okay, that's the N minus 1, right? So then Jenna's, her stuff's just a little bit different. Hers is A equals not 6, but 21. Her D is still 15. And her N is the 11, because hers actually matches up. She's not counting the 0 year. So hers is straight 11. And so then you're going to go T of 11 for Jenna is 21 plus 11 minus 1 times 15, which gives you 171. So see, the point is they got the same answer. But as we both noticed, Joel's was a little bit more confusing, because if you forget to count 0, you could be in trouble. Yes? Exactly, yes. It's a matter of knowing where you are. Okay, so both strategies are correct ways of doing it. So if you want to use the whole set they give you, the start with 6, make that your T1, just make sure you understand that's your kind of 0 year. Okay, yep, definitely fine. Term the formula for general term of Joel's arithmetic sequence. So they just want to simplify his general. So that's just with the N's being blank. So his T sub N, that just means you have A and D, and you just simplify with n, remember? This is like your pattern or your formula in terms of a line. A couple of you guys missed this on your Shobi. You guys either didn't simplify or you just gave me d. When it says general term, it wants like the form you would use, the formula you would use even, to find a specific year, okay, or a specific place in the pattern. Okay, so you distribute that. So we're here. And then we just combine the 6 and the negative 15. You're going to have his general term now. His general term is 15n minus 9. That's his general term. Okay, any questions there? All right. Okay. Other one, she's going to be 21 plus n minus 1 times 15. Same thing. T sub n equals 21 plus 15n minus 15. T sub n equals 15n plus 6. So just so you understand that this isn't really completely different, they both have the same slope, right? And then how far is negative 9 from positive 6 in terms of like a distance? Don't overthink it. Well, what's it growing by? What's a tree growing by? 15. They're 15 apart. So that's all it is. It's just one spot over, right? Because this person started after the first year growth, this person started at 0. So I'm just showing the difference between these, that negative 9 and 6 is 15. It's just one place. Yeah. Okay. All right. So we've already exhausted D. We've talked about it a bunch. You're probably tired. Explain why the formulas are different. Just wherever you want to summarize there if you want, or if you get it, you don't want to put anything there is fine, but we've explained why it's different. The 0 year versus the 1, starting where the tree before its growth, all those things we mentioned for D there. So if you want to put in your own words, great. Okay, and we'll all kind of get started on E here as you're finishing there. So if the tree continues to grow at the same rate, in which year will it reach 28 feet? So first of all, our formula is in inches. Okay. Okay, so yeah, so we convert 28 to inches so that we're in the same growth rate because we're talking about growing per inch. So you just go 28 times 12 real quick to make this inches, and that gives you 336. And so 336 is what we're looking for, the ending height, right? And so how would we use, we'll do both of them still just for practice, but how would we use their general terms to solve? Where would it go? Yeah. Not n, because it's not the 336th year, right? It's a t of n. It's the output of the n. And maybe that's what you meant. But it's 336 goes here. Well, let me write what it has here. So remember, his general, I'm doing Joel's here first, and then I'll do Jen over here. Again, you don't have to do both of them, guys. It's just so you can see both sides. He was 15n minus 9. Yeah. Okay, so this is the 336. The output of the n. We're solving for n because it's asking us what year. Okay? So 336 goes right here, and so now you should feel comfortable in solving this. All right? Same thing for Jenna's. If she would have 336, but her formula is 15n plus 6. And you just solve those two equations. And so you'll see they're one apart. Plus 9. You get 345 divided by 15n. Divide the 15. So 23. Okay, so it gets 23. And then when she does it, she gets 22. So again, the important part is that still is the same year. I know they're different ends, but it's the same year. If you said 23 starting at 2000 and counting 2000, that means you're going to where? 2022, right? Because you're counting 2000. She's not counting that year, so she essentially starts at 2001. 22, she's going to be 2022. Okay, so they both get 2022 for their answers. Okay, so that 0 year, don't let that 0 year fumble you up. Okay, any questions so far? Okay, we're just going to kind of go through a little decay problem now. So instead of growing, we're decaying. Okay, so Look at this one here. So a printing press was bought in 1992, depreciates in value by the same amount each year. 5 years after it was bought, the printing press has a value of $311,000. It had scrap value of $2,900 in the year 2010. So it's important to understand here, do we know what it was bought for? No, we know the 5th year and we know the 2010, so that looks like the 18th year. So what to understand is we're going to go T5, okay, is 311,000. And we're going to go T18 is 2,900. Now, since I put it this way, what does my terms represent? So like when I say T5, is that after 5 years or before 5 years? So see out here? 5 years after. So the reason I'm asking that is, does T1 equal initial value? Does T1 equal initial value? So I want you to think about the wording of how we've labeled our terms, and I want you to answer the question, if I want to find how much the printing press was off the line when I bought it, is that represented by T1? Why? What does T1 mean? 1 year depreciation. Great. So what I'm telling you is that once we figure out the D, we'll get T1 and do what to? We'll add one more. We essentially kind of want T sub 0, even though that's not really a thing. Okay, that's initial. You guys did a good job there. Last class didn't see that. Okay, so T1 is your first year of depreciation, not your first year of buying it. Okay, all right, so what's the strategy we can use? If it's an arithmetic sequence, what's the strategy we can use to figure out D? Yep. Okay, you could do that. Yeah, you can do that. I'm just going to go ahead and leave them. I'm going to do that slope, though, if that's okay, Jonas. I'm going to go 311,000 minus 2,900 over 5 minus 18. Remember? Y minus y, x over x. Now, what I want to notice here is are you concerned that we're going to have a negative? Is something wrong, or does that seem okay? It's going down. We're expecting a negative, okay? Okay, we're expecting a negative. It's depreciating. Good. And when you do that calculation, guys, you should get 23,700 is what it's depreciating by. Okay. That was the only thing it wanted here. We've kind of went off the grid a little bit talking about the initial value. That's for B, but that's the only thing they wanted for part A there. Any questions on that? So your D is 23,700 down, so negative. All right. So if that's the case, what we're going to do is we're going to go figure out what T1 is, because we kind of know the formula for that. Okay? And so we want to figure out what T1 is, and we get T1. We know we get T1. We're going to add 23,700 to get initial. We just talked about that, right, to get the initial price. So we're going to find T1, because that's technically our A. Okay, and how can we do that? How can we do that? Think about that for a second. Whenever we talk general form, we're talking about this form. And what I'm telling you is that we have term numbers over here. We have T. I'll use the smaller one. Well, it doesn't really matter which one you use, but I'll use T18 because this is a 2,900, a pretty small number. So I'm going to use this. I'm going to put in 2,900 here. I'm going to put 18 for N. We don't know A, but we know D is negative 23,700. This is kind of where they expect you to be a little bit, I would say, comfortable with your algebra, okay? Because now we're just solving for A. So you're going to go A plus 17 times negative 23,700. Somebody do that one for me. What's that? Sorry. 402,900? Yeah, thanks. So it's negative 402,900. And it's a negative because remember we were decreasing. And so now we're going to add this over like so. And that's what our A is going to be. So our A would be 405,800, right? Okay, that's your A. But again, that means that's what though? The first year of depreciation. So as we came up here, we're talking about. So we just found this. Okay, to get initial value, we're going to put this right here. And now we're going to add these to get the actual cost when it was brand new. Okay, the actual cost when it's brand new. So your initial value is actually, in fact, $429,500. That's how much the printing press cost. Okay, so rather expensive, and it lost money quite quickly. Okay, any questions with that? Okay, so last kind of example investigation piece here. So we can relate arithmetic sequences to linear functions, which we've already known from our pictures in lesson 1. A pile of bricks is arranged in rows. There are 28 bricks in the first row, and the number of bricks in each row is 2 more than the previous row. So there's row numbers of bricks. So we know the row numbers we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Number of bricks, they said the first row is 28, and it goes up by 2 each time. Okay, all the way to 46. And then with the illustration of the graph, and I'll wait for you here, but the illustration of the graph, row 1, 28, it goes like this every time. And so you see that linear relationship. Okay, and I'll pause here, catching up, and then we'll answer the questions below it. See if you guys remember your Math 9 and Math 10 stuff a little bit. What does range go with? Y value. When you're talking about range, you're talking about your outputs range, okay? So the Y's. So determine the range of if it's an arithmetic sequence. So what's the range values of that chart we just made? Is it the rows or the bricks? The bricks. So the bricks are the range. And so was the bricks, were they arithmetic sequence? So did they have a consistent growth? Yes. So yes by 2 for common difference. You just put CD if you want. So yes, the arithmetic range was arithmetic sequence by a common difference of 2. Okay, conversely, the domain, okay, the domain of this group would be the rows. How can we describe using our rational numbers description? So the rational numbers are natural, whole, integers, rational. Which set of those would describe our domain in this case? See if you guys can get this. Okay, well it is real, but I want more specific. Because there's some real that don't work. It's natural. Why is it natural? Do you know why? There's no 0 row, and you can't have negative rows. So when he said real, real is all of them. All of them's in the real number system, right? So technically, I could argue saying, well, no, we can't have 2/3 row, right? And so since our rows have to be whole numbers, we describe that as natural, because they're whole positive numbers, okay? So you would say natural numbers. Okay? And what you can do here for like math, for you need this for 30, you can just do like that. X equals n, n's natural. Okay, why does the graph not have intercept on the vertical axis? We kind of answered that with our natural numbers, and Isabel kind of already said that. So somebody besides Isabel, why do we not have a y-intercept essentially? What's that? You're close. That's the y though. Yeah, there's no 0 row. Yeah, so there's no 0 row because right to find y-intercept, you have 0 for x. Our x in this case is rows. But Callum, your concept is right. So there's no 0 row. Okay, good. and then write the equation for the number of bricks as a function of r. So they want you, this is writing in general again. So we're taking t sub n equals a plus n minus 1 again, and we're writing this with r. So r is going to replace n in this case. So t of r, so we'll say row number, is going to be, we know a in this case was what? 28. And we know it's plus, we don't know, we're going to leave r there, and the color difference is 2. So we're just going to simplify that. So you'd get 28 plus 2r minus 2, and we are done. So that is your general term for that establishes the bricks and the rows. Okay? All right.